A prime number is a number that is not divisible by any other number. In other words, I mean, of course, one, if you consider one as a divisor, then one divides every number. And every number is divisible by itself. So if you exclude those, other divisors are called proper divisors. So proper divisor means a divisor that is not equal to 1 or the given number. And prime number, proper divisor is a divisor that is not 1 or the given number. Okay, so prime number is a number that has no proper divisor. So that has no number other than itself or 1 that divides it. So examples of prime numbers are the lowest prime number is 2. 2 is only divisible by itself and no other divisors there. 1 is not considered to be prime. 1 is not considered to be a divisor for any number. So 2 is the lowest prime. 3 is the next one. 5, 7, 11, 8, 9, 10 are not prime. 11, 13. The list goes on. It's a long list. But the only rule is that there are no divisors. They're not, I mean, almost all of them are odd numbers except the first one. All other numbers are odd because if it is even, it's going to be divisible by 2. So 2 will be a divisor if it is even. So the rest of the prime numbers are odd numbers. But anyway, you cannot assume odd number is a prime, but prime numbers are odd except 1. But anyway, when you write program to determine whether the number is a prime or not, you have to use the definition, which is a prime number doesn't have any divisor. So let me explain one way of doing this. The program is, the question is, write a program that'll get a number from the user and determine whether it's a prime or not. Okay, so and by the way, it's going to come up in the in some of the feature assignments also. This, and so you need to know, and that's why I'm going to explain this. Okay, so we are going to get a number from the user and determine whether it's a prime or not. So I'm going to begin with main and declare int num. Num is where I'm going to store the number. And then I'm going to use test numbers to find devices. And that's all I need. I also need a counter. Okay, so let's, because the approach I'm going to use here first is counting devices. That's one way, but it's not the better way. I will explain the better way after this. You will understand it better if I explain both ways. The count is going to be starting at 0. The count is going to count the devices. So I need to get the number from the user. So ask the user to enter number. And then cin num. Okay, the next step is to determine how many devices are there. I'm going to count the devices. So a divisor would be a test number for divisor would start at 2 because 1 is not considered to be a divisor. So you have to start at 2 and keep increasing to 3, 4, 5 and test all the numbers all the way to half of the given number because no number is divisible by any number bigger than half of it. So even if the given number is odd, if you take the half of it and take integer part, I mean, if you divide by 2, then it'll be integer part of the half. That will be the largest divisor, integer part of the half. So I'm going to, I can use a for loop for tests going from 2 up to test less than or equal to num over 2. Num over 2 is the largest number I need to test, incrementing tests by 1 each time. And each test has to be tested to see if it divides the number. So I need if statement inside the for loop. If num modulus test is equal to 0, then the test is a divisor. And if you need to print the devices, then you would say see out tests here. But I don't need to print the devices. I need to count them. So I just increment the count. Whenever a test number divides the num, I increment the count. And regardless of whether this test number divides it or not, divides the num or not, the test will be increased here. And the new test number is compared against num over 2 here. And then if it is under num over 2, we will be testing it again, testing the next number here, right here. And if it is divisor, counter goes up. If it's not a divisor, counter doesn't go up. Still, test number increases. You have to make sure test number increases each time. So this loop will take care of counting all the devices. So when the loop ends, outside the loop, I need to see what this count is. Now, if the number is a prime number, what would be this count? If the number is to be prime, what can you say about the count? I just explained the prime numbers a minute ago. So if this num that was entered by the user is a prime, then what do you expect this count to be? Okay, so nobody understands the prime number? If you understood, you should be able to answer this question.
Maybe 1.
1, why? Which one would that be? Which number is the
But you said if the number is a prime number, right?
If the num is holding a prime number, then what can you say about the count is my question. And you said count will be 1.
No,
Why?
count will be equal to 0. It will be equal to 0 before, but once it goes through the loop, then it will go up if it's divisible by test and equal to 0.
If any test device num, then the counter will go up. And if the num is a prime number, then what can you say about the count? That's my question. Can you give me a simple answer? Anyone? So still no one is understanding prime numbers. That's what I had to think.
It would be 0, right?
It will be 0. That's a simple question. It's a simple answer. If the number is a prime number, none of these test numbers would divide it. So counter will never go up. Everybody understand that? Only one student was able to answer that correctly.
Yeah.
Okay, Neil, you understand that, right? It won't be
I
1.
understand it now.
It will be 0. It will never change from 0 because none of these test numbers would have divided it. So after the loop, I can say if count is equal to 0, then see out prime. isn't it? The number is prime if count is 0. Else, you have to write a conclusion. The problem, your program cannot leave out a conclusion. Okay, the conclusion must be provided in any case. If count is 0, then number is prime is the conclusion. If the count is not 0, then not prime. As simple as that. If there was any divisor, then it's not prime. Okay, that's it. That'll be one way. Now, this is not efficient. Now, in programming, efficiency is important. You know exactly if a program runs unnecessarily slower than it should, then that's not good program. And so efficiency means improved runtime. It runs faster than the fastest possible. So you should always try to write the fastest possible program. And in more advanced classes, that's all you will be focused on. How to improve a program, how to make it faster. Those are the focus you will be having in the classes like algorithms. That's your focus on that course. Anyway, the first two courses are the programming, 271 and 272. After that, advanced things will be discussed, such as improving speed of a program. And so improving the speed of a program is a very important concept in the entire programming. So sloppy programs should not get much credit. This program is not very efficient right here. It's very clear it's not efficient because it is going through the testing of all the numbers from 2 up to the half of the given number before concluding whether it's a prime or not. But you don't really have to go that far. You don't have to test all the numbers. If any number is a divisor, we should immediately stop and say, this is not prime. Instead, this program is checking everything from 2 to half of the number. So can we improve the efficiency? That's our question. Yes, by doing this, by testing the numbers, and whenever any test number divides the number, the loop should stop. It should stop testing the other numbers, and it should conclude that the number is not prime. And only if the current number is not a divisor, then the next number should be tested. So how do we do that? That was explained in that video lecture. I explained this method first, and then I explained why this is not efficient, and then I explained the better method. So I'm going to explain the better method. Now you're going to have to learn this. It's important for the idea I'm going to use in the next version of the program. Is important in more advanced classes, also in the rest of the course. Yeah. And that's why I'm going over this. So what I should do is, as soon as a test number is found to be a divisor, the loop should terminate. Loop should not go on to test the other numbers. So how do we do that? To do that, we need to use a new technique called flagging. Flagging is a concept that's important in computer programming. You set up a flag that would have one value and then change to some other value to flag something, to flag that something has happened. So I'm going to show you how to use that. Int, I'm declaring the same variable again, num test. These are needed, but the count is no longer needed. Instead, I'm going to use a flag called isPrime. IsPrime will be the flag that will be, I can set up the values. The programmer decides what value will be the flag. So I'm going to use 0 to mean the number the num is prime. So as long as num is prime, is prime will remain 0. And anytime when we conclude num is not prime, I'll change this prime to 1. So the flag will be changing. So as long as this prime remains 0, the num is assumed to be prime. So that's my flag value. I decide what value. You can choose 1 and 0 in the opposite way, whichever way you like. So the programmer decides the value of the flag. Anyway, we still need the test number to test, but only thing we will not do is continuing to test all the numbers after finding a divisor. That we have to stop. So we will ask the user to enter the number. Cin num. And then I'm still going to do the same for loop for test going from 2 to test less than or equal to num over 2. I still have to do the testing, but I'm leaving some space here. Second. Okay, I'm leaving, going to leave some space there and put semicolon. Test plus plus. Okay, and then I still write that same condition if num modulus test equal to 0. Of course, I have to test devices. So if num modulus test is equal to 0. If any test number divides the num, I will just, all I need to, I'm not counting anymore. I know if any test number divides num, in other words, if this condition is true, then num is not prime. Right there, I can conclude that, right? So I set these prime to 1. Okay, so anytime a test number divides is the num, then the flag changes to 1. If none of the test numbers divide, all the way it's going to go from 2 to all the way to half of num. And if none of them divides, then its prime will never change to 1. Its prime will stay at 0. And so after the loop ends, I can say if is prime equal to 0. After this whole loop has gone through, if its prime is still 0, that means number is prime. Else, Cout not prime. Okay, now still the value of this method is not visible yet. I'm going to explain that. So it looks like, I'm doing the same thing like before, even after test number, a test number is found to be a divisor, its prime changes to 1, but the loop continues on. The test numbers will still increase, and I will be testing the next number even after test prime changes to 1. That's where we need to change that. We need to stop the loop when this prime changes to 1. We can do that just simply by adding second condition to the loop control. Is prime equal to 0. So I hope everybody can see how I wrote that. Test goes from 2 to less than or equal to num over 2. So the loop control condition is test must be less than or equal to num over 2, and its prime must remain 0. Only as long as is prime remains 0, keep testing new numbers. That's what I'm doing. So when prime changes to 1, whenever you find any divisor, its prime changes to 1. As soon as its prime changes to 1, the test, even though test number will go up to the next number, and then we will be checking this condition. This condition is now false because its prime is not 0 anymore. So when its prime changes to 1, the loop will terminate. It will not test any more numbers. That's why this is efficient method. So, a slight change from the previous. We introduced the flag variable and set it to 0 at the beginning to mean the number is prime. And then whenever test number is found to be dividing the number, its prime changes to 1. And as soon as its prime changes to 1, the loop will terminate because the loop control says test must be under number over 2 and its prime must be 0 for the loop to continue. So this is a very efficient program. Now we will not be wasting time testing all the numbers after finding a divisor. Whenever you find a divisor, the loop terminates. Only if none of the test number divides, then the loop will go all the way to testing all the numbers from 2 to half of the number. And the loop will terminate testing all the numbers, after testing all the numbers, and the prime would have stayed at 0. If none of the test numbers divided, its prime would have stayed at 0. So when the loop ends, its prime would be still 0. Anytime its prime changes to 1, loop terminates, and program will write the conclusion number is not prime. I hope you can understand this program. This is important. The idea of using this flag variable is prime is the key point here. And because of that tool, this program is important because this is the only one we are going to be doing at this point that uses the flag variable. Any question on this? You should be able to rewrite this if the question comes up in a test. Okay, this is an important program. It may come up in the third exam, final exam, anywhere. Only if you understand it, you'll be able to write it. Now, nobody can memorize a computer program and write it correctly. Okay, you have to understand the logic behind it, and then you will be able to remember it. You have to understand the whole thing. So if anybody's not understanding it, feel free to ask me to explain any part of it or the whole thing again. All right, now this program is there in your book, and I think it's 4.4, I believe. And in the video lecture, I explained the idea and wrote this program for you. So sometimes the programs that are discussed in class will show up in the test exam, same program, to see if you understood it. All right, so moving on from that, we're going to go over this section 4.5 part 2. That was the video you were supposed to watch before today. And in this section 4.5, the latter part, you learn how to get data from user and accumulate some of those data or some of something, anything, based on the data entered by the user. So the user has basically several data. Like any statistical analysis, the user is going to have some statistical data, and your program is going to have to get all of those data and do the analysis. And in the next project, you're going to be doing this, getting data from user and carrying out some task with that data. By the way, the last projects I was holding off the grading because I was too busy with other things, but I have graded them now, and you should take a look at that. Look at those programs, the projects. And you can ask me to explain the projects, the past projects also. Future projects will not be explained. You have to do it on your own. The past projects, if you want, if anybody wants explanation, you can ask for it. All right, so you learned two ideas, two methods of getting data from the user. That were basically, how to control the loop. You had to have a loop that will get the data one after the other, and then you're going to manipulate the data in some way, whatever way you need to use. And there were, for the loop control, there were two methods. One of them is loop control by the count. First one, control loop by count, and that's called counter control loop. So in this method, what you do is you first ask the user to enter the count. Basically, you're going to write a loop to repeatedly get the data, but how many times the loop is going to repeat. That depends on how many data a user has. So one way to control the loop is to get the number of data from the user. Ask the user to enter the count, and then make the loop go that many times. That way you will get only that many data from the user. That's the counter control loop. And second method is controlling the loop by sentinel control. I'm just briefly describing this. You're supposed to have watched the video to understand all those ideas. Sentinel control. That means this is applicable when the user doesn't have the count. Now, the user doesn't always have the count. You cannot expect the user to do too much work. That's what the computer programs are for. So user doesn't want to count if the number of data are too many. Usually statistical analysis problems have too many data, like income of everybody in New York City. If you're doing some analysis with the income of everyone in New York City, that's too many to count. So user has the data, but he doesn't have the count of the data. So that's when we use sentinel control. What we do is the programmer decides to use some kind of number or character that is not going to be one of the data, and ask the user to enter that character or number to signal that he or she is finished entering the data. So the user will continue to enter the data, and when he or she doesn't have any more data, he or she will enter that special number or character, which is what we call sentinel. So sentinel, if all your numbers are expected to be positive numbers, all your data, then -1 can be sentinel or 0 can be sentinel. If all the data are expected to be characters, then it's appropriate to use a character as a sentinel, because the characters are equivalent to numbers, and therefore if you use numbers, it's not wrong, but it would be appropriate to use a character. So we usually use some character like a $, or a null character, blank character, something like that. But blank character is risky. User may enter a blank and it may not recognize as a blank, that's risky. So you should use an actual character. Okay, so the user will enter that character or number when he or she is finished entering data. So the loop would be controlled by that. So those are the things, and you saw some examples in the video of counter control loop and sentinel control loop. Now, there's no point in repeating those, and that's why I have different new problems to go over. The first one says, write a program that first obtains the number of data user has, and then obtains the data. So that's how counter control loop goes. You get the count first. So get the data one at a time and compute the average of the reciprocals of them. So you need to compute the average of the reciprocals. That means you need to add up the reciprocals of the data and also count how many data. But in this case, the count will be given initially. So,
Call from Princeton and Boone.
sorry about that call. I'm going to let that go to the message. Anyway, here we need to get the count from user. So that is our count. So we don't need to count the data because the count is going to be given. And then we will get the data one at a time. And then we need to add up the reciprocals.
To remind you that you have a medical appointment on Wednesday, November 17th at
All right, sorry about that. So the count is going to be entered by the user, and then you need to repeat your loop that many times. So I'm going to go over that one. Okay, so let's start with the main and declare the variables. Int data count. I'm going to use data count as the count, that's the count entered by the user. And another counter is going to count how many data we have obtained so far. Of course, we have to make sure the loop goes this many times. Loop goes data count many times to repeatedly get the data. So we need to have a counter that counts how many data we have so far obtained. And so that counter is going to start at 0. And then I need to add up all those reciprocals. So that's going to be float because there are some of the reciprocals. So float sum. Now, when you accumulate, you need to have a sum starting at 0. It has to have a value, and it makes sense to have 0 as the initial value. And that's all I can think of right now. At the end, we're going to calculate the average of the reciprocal. So let me create a variable for that. It's going to hold the average. Okay. Now, the first thing we need to do is ask the user to enter the count. Enter count of data. Okay. And whatever the user enters needs to be captured in the data count. And then the counter is going to go up to data count. So I can use a for loop, but I'll use while loop for now. While data count, I'm sorry, count is less than or equal to data count. The count represents the count of data obtained from the user, and that count should be less than or equal to data count. Okay, while that is true, I need brackets, cout, enter data. So as you can see, I'm getting the first data right here inside the loop. And cin, I need a variable for the data itself, and I will declare num, float type num for the data. So cin num. I'm getting the very first data right here, and count will increase right here to 1. Now, you can see that I started count at 0. You had to adjust your count values of the count to make sure the count is going right. My count was 0. Only after getting first data, the counter becomes 1. So the counter is counting exactly how many data we have. And then I can do whatever I need to do with the num right here in the loop itself. So what I want to do with the num is I want to add reciprocal of the num to the sum. The sum is going to add up the reciprocals of all the numbers entered. So for that, you need to say current value of sum plus 1 over num. Now, num is already declared as a float one, so I don't need to worry about data types. If 1 is integer, if num is also integer, this division will go wrong. But num is float, and therefore the division will be fine. So I'm adding 1 over num to the sum and put the result in sum. That's how you add up data. In the test, accumulation was there, I mean, in the previous section 4.4, we accumulated sum of series. And I explained, many times we did problems like this, and I explained, why you need to do sum equal to sum plus 1 over num. But I was surprised to see 2 students wrote it like something like this, sum equal to 1 over num. So I'm going to explain why this is not accumulating. This will not accumulate some of the numbers. So let me quickly explain what happens if you do that. Okay, we got the num. So let's say the user entered 5, then 1 over 5 is stored in num. Sum. Sum was 0, and now it's replaced with 1 over 5. Okay, sum was 0, and now it's 1 over 5. Okay, and now you go back, as long as, let's say, count is less than data count. So you're asking for the next number. So let's say the next number is 10. User entered 10. And what's happening? 1 over 10 goes into sum, erasing the previous number. The 1 over 5 is gone now. You have 1 over 10. See what's happening? You're just replacing sum with the new number. That's not accumulating. But if you do sum equal to sum plus 1 over num, then original value was 0. The sum was originally 0. And during the first execution, when the user enters 5, 1 over 5 is added to 0. That's why the sum has to have a value 0, because you're saying to the value of sum, add 1 over 5. That's what you said. That's what you're saying. There must be a value for sum. Otherwise, this cannot be executed. So it was 0. So now it is changing to 1 over 5. Okay. 0 plus 1 over 5 goes back in sum. So that's 1 over 5. And then in the next iteration of the loop, now you go back and the count is less than data count. You're asking for the next data and the user is entering 10. Now what is happening here? 1 over 10 is added to current value of sum, and the result goes back into sum. So the sum now has 1 over 5 plus 1 over 10. You see that? It's accumulating the sum of them. And when the next number is entered, the new number is added to the current value of sum, and then it's stored back in sum. So this is the only way to accumulate. If you don't write sum equal to sum plus, then you're not accumulating, you're just replacing. Okay, so this is all I need to do in the loop. Sometimes you have to do other things. Let's say I also want to find the lowest of all those numbers. All the data entered, I want to find the lowest. Okay, let's say that's another goal, another task in this program. Then I had to declare the lowest up here, the variable lowest. No, it needs to be float. And then I can start the lowest with any number or with nothing. And when I get the first data, I need to store it in the lowest. Okay, so the lowest needs to be, okay, you had to adjust the program a little bit. You had to get the first data before the loop if you want to do this minimum. You know, that was not my goal initially, and that's why I didn't write it that way. But since I have written this so far, I don't want to erase and start over. So I'm going to assume all the numbers are going to be positive in this program. If they're all positive, if you know that, then we can start the lowest at 0. And no, the lowest has to be something large. So I'm going to make an assumption here that the problem tells you that the numbers are all smaller than 1,000. Then I can start the lowest as 1,000. This is not a good way to do lowest, because when you don't know anything about the numbers, you don't know 1,000 is a larger number than all the data. So I don't recommend this technique unless you know some information about the data. In this case, I have to use this assumption. I have to make that assumption to continue to do this, because I already have started. The better way is to get the first number before the data, before the loop, and store that data in the lowest. You're actually starting with one of the data and then compare all the other data to it. That'll be the better way. So I'm going to do this using this method, set the lowest to 1,000, and then say inside the loop, after getting the actual data, if num is smaller than lowest, so if the num is smaller than the current lowest value, then replace lowest with num. So the lowest is supposed to hold the lowest, and it started with 1,000, and assuming all the data will be smaller. So the very first number is going to be smaller than the current lowest, and therefore lowest will take the new number. After that, the loop is going to continue, and we'll be going up to the top of the loop. And as long as the condition is true, we ask for the next data, and the next data is received in the variable num. Counter goes up, and we are adding the reciprocal to the new sum and putting it back in sum, and also comparing the num with the lowest, current value of lowest. If the new number is smaller than the lowest, then num will be copied into lowest. So anytime we find something smaller, that should go into the lowest. If I throw in this if statement, then I'm finding the lowest number among the data. If I want to do that as an additional thing, then I can do that. And then I continue, and then I close the loop right there. So the loop will repeatedly get the data. As long as count is less than or equal to data count, it'll ask for a new number, and the new number is processed. In whatever processing you want to do, you're adding reciprocal, and also you're finding lowest, you're doing this. All those processing will be done in the loop.
Wait,
And
Professor?
Yeah.
Reciprocal, that'll be 1 plus over num, right?
What do you mean 1 plus?
Not 1 plus, I mean 1 point over num, because it's float, right? Or 1.
That's what I was explaining. I have to worry about that. I have to insert a 1 point if num is integer, but num is declared as float, right?
Okay.
So whatever the data user entered is converted to float. So therefore, because we know we are dividing, we are doing a division with the num, so we need to have that float so that the 1 over num will be correctly computed. So that's why I made sure num is declared as float. So I don't need to worry about 1 point. Okay, so this part is adding up, and this part is finding the lowest. And whatever, any other processing you want to do, if you want to find maximum as well, you can do that here too. You can throw in another if statement to track the maximum. So do all the processing inside and then close the loop. And then when the loop is finished, we have the sum ready. All the reciprocals have been added up. So we are ready to do the things we need to do after the sum is finished, which is to find the average. Average equal to sum divided by data count. We already know the data count, so we don't need to count the data. That's why I didn't introduce a counter. So divide sum by data count, that's your average. And you need to see out that average. And also, if you needed the, if you need the lowest, then print the lowest. With some description. I didn't write any description. You had to describe your data, your values, and close. Okay, so you can see how my indentations are done. When the while loop is written, it's best to write even the curly bracket, beginning bracket, indented. Some of you have a habit of writing it here. I accepted that in the assignments, but that's not the best way. The program is easier to read if you indent the whole thing that comes inside the loop, like I have here, even the brackets. And then whenever you write if, you need to indent whatever that is inside the if, right here, this. So this indentation, you need to make a habit of doing this indentation. And so many students are still not doing the indentation properly and getting penalized for it. I don't know why it's so difficult to do this indentation. I don't know why they are refusing to do it and getting penalized. All right, anyway, that's the program with the counter control loop. Any question on that? Okay, so all counter control loops will work the same way. You need a data count variable to store the data count and then get the data count before the loop begins.
So this one helps in getting the reciprocal, right?
Yeah, in this particular case, you're adding up the reciprocal. That's our task. But whatever the task you need to do that in the loop. In this loop, this task, the two tasks we are doing here. Whatever the task in another problem is, that's all you need to change. You need to change this part. Other than that, the rest of the program will be very exactly same as this, if you're writing a counter control loop. Okay, any question on that? Okay, then this second problem. Now, clearly everything is going to be same as this, except the processing part, right? So you do need a counter. The count plus plus is necessary, and you need to get the data inside the loop. So all that is necessary. Only this processing part has to be changed for the problem number 2. Okay. Can somebody tell me what should I write here for the second problem? Inside the loop, I need to ask the user to enter the data. So I need these two statements. And then I also need to increase the counter. This counter is controlling the loop, as you can see. So the counter is needed. And everything else is the processing that we need to do. And according to the problem number 2, we need to determine how many data entered were odd.
We use if statement.
You need if statement, yes. If
Num
okay, anybody can answer it. There are so many of you.
would it be equals 1 or no?
Num equal to 1? No. Num is our data. It doesn't have to be 1. Only Neil is at least attempting, and everybody else is quiet. Can somebody tell me what to do? We need to determine whether how many of these numbers entered by the user are odd. You learn how to determine whether a number is odd or not. Really, I need another counter to count how many numbers are odd. The count here is counting how many data are being entered by the user. That's needed to control the loop. That's not counting the odd numbers. So I need to introduce another counter up here, odd count, started at 0. This odd count is going to count how many odd numbers were entered. And so I need this if statement to determine whether the number entered by the user, the last data we got in the variable num, whether it's an odd or not, we need to determine that. If it is odd, then I need to increment the odd count. Okay, so you just had the test. There was a question in the test that asked you about odd even, determining whether the number is odd or even. So nobody can remember how to determine whether the number is odd or not.
Is it odd if it's not divisible by 2?
Not divisible by 2, right? Okay, so how do I write that?
So if num modulus
2?
2, okay.
equals 0.
Is that right?
No, not equal to 0, my bad.
Not equal to 0, right? Or equal to 1. When you divide any number by 2, the remainder can be only 0 or 1. So not equal to 0 is same as saying equal to 1. Okay. Okay, Neil, you understand?
Yeah, that's what I meant to say before, but I just couldn't.
You skipped you didn't say the modulus 2, right?
Yeah. I forgot that one.
Yeah, num doesn't have to be equal to 1 to be odd. It's just num modulus 2, the remainder of dividing by 2 should be 1 instead of 0. I'm surprised that only 2 students have some knowledge of this. You know, this came up so many times in the assignments. I don't know why the other students are not able to learn this. Anyway, if num modulus 2 is equal,
Then count will increment by 1.
right, which counter? Odd counter would increment by 1, right? Odd count plus plus. And that's the only processing I need to do. So close the loop right there. And when the loop ends, I see out odd count. So, you just learned how to do this counter control loop. So only this part will be changing in the loop for any other problem. All right. Now, sentinel control loop. I explained a few minutes ago what sentinel control loop is. If you are using sentinel control loop, then the programmer has to decide what would be sentinel. And you had to tell the user to enter that sentinel when he or she is finished entering the data. Okay, and so this problem 3 says, write a program that repeatedly obtains float type numbers from the user until he or she enters -1. So it is suggesting a sentinel right there. If it suggests a sentinel, you should use that. Otherwise, you can make up your own sentinel. And finds and prints the smallest of them. So here we are trying to find the smallest. Finding the smallest is an idea that was learned earlier in this, in chapter 2, we discussed that. And then after learning if statements, no, chapter 3, I'm sorry. Chapter 3, we learned that technique. We applied for small number of data. And then later in chapter 4, after we learned about handling larger number of data, we learned how to do that with any number of data. And then it was in the test. And to my surprise, no one answered it correctly.
No, but it's there.
I'm sorry?
What?
I'm not happy and sleep. My legs.
I'm sorry, somebody's speaking, but I can't understand. Is that a question? All right. Okay, so I was surprised that no one was able to do that correctly. What you need to do is to find the lowest number, you take the first one as lowest. You need to have a variable to hold the lowest. It's like if you have 10 numbers in front of you, to begin with, you take the first number in your hand and then compare that to the other ones, to the next one and the next one. Anytime you find something smaller, you need to take that into your hand and then compare what is in your hand to the rest. You don't compare them to each other. If you compare those 10 numbers to each other, that's too many comparisons you're going to have to do. That's not efficient way. And that kind of programming will not get any credit. You have to use the right way, which was explained in class. You take the first one in your hand as the smallest, and then compare to the next one. If it is smaller, take that. Otherwise, ignore. Compare what you have in your hand to the next. If it is smaller, take that. Otherwise, ignore and go on. With that strategy, if you compare all of them to what you have in your hand and take the smaller one whenever you find one, at the end, you have the smallest, and you only compared each number in your list once to another number. And that's the minimum number of comparison you can do. And if you do any more than that, you're doing too many. So the technique is to take the first data as the smallest and then compare it to each one. And whenever you find smaller, copy that into smallest. So that's the technique. So here we need to get data from the user and we don't know the count of the data. And we need to compare all of them and find the smallest. Okay, so let me write that. Main. The data are float type, so float type num. Num is going to hold the data. And then smallest is what we are finding, so min. I'm going to use the proper technique to find the min. In the previous program, the technique I used is not really acceptable unless you know the 1,000 is larger than all the data. You don't normally know anything about data. So the min is going to hold the minimum and print the smallest of them. That's all we need because we are just finding the smallest. Okay, and so we ask for the data Now with the sentinel control loop, you need to see, you need to say this, while the data that we have currently is not equal to sentinel. That's how you need to write. While num is not sentinel, keep getting data and processing them. When the num equal to -1, loop should terminate. And that's why the control of the loop should be while num is not -1. Okay, so that means the num must have a value to begin with to compare it to -1. So some students may say, okay, set num to something like 0 so that the loop will start. But that's not recommended method. I will write it that way later and explain why that's not recommended. That's not a good way to do it. But right now I want to do it the right way, which is to get the first data before the loop begins. That's a better way. So ask for the first data here. Enter data and see in num. So you have the very first data in num. As long as that num is not -1, the loop will continue on. Okay, the loop inside the loop. In this method, inside the loop, you need to do the processing of this first number. That's how you do it. Since we are finding minimum, I'm going to do something before the loop begins. And that is to copy the very first data into the min. Min equal to num. So the very first data is copied into num, min, and then all of the other numbers should be compared to min. So, but the loop control is going to be still sentinel. So while num is not equal to -1, I still need to process the first data. Even though I have processed the num, if I have copied num into min, I still have to do this processing statement as the very first statement. So you will see in a few minutes why. If num is less than the min, current value of min, if the new data is less than the new data right now is same as the first data, but I still have to do this. If num less than min, which is not going to be true initially. First time through the loop, the num and min are same, right? I copied the num into min. They're equal. So this condition will not be true, but I still have to write this as the first statement, and you will see in a minute why. If num less than min, then min equal to num. If new number is smaller than min, copy that into min. And then proceed to get the next data. So I'm going to ask for the next data. Okay, so this is the right way to write it. You do the processing of the data first, because you are getting the first data before the loop, and you process that data. The processing here is comparing it to min, and then get the next data at the bottom of the loop, because that way, after getting the new number, you are going to the top and comparing it to -1. Only if the data is not -1, you are processing it. So the -1 will never be processed if you write it this way. That's why I had to do this processing statement before at the top of this loop, even though initially num and min are equal, and therefore this condition will not be true initially during the first iteration of the loop. I still have to write that this way, because after getting the new number should be compared to -1, and then the new number should be compared to min. So therefore this order is important. If it is not -1, you are comparing it to min. Otherwise, you will end up processing a -1, and the -1 may be the minimum. -1, if all the numbers are positive in your list, then you end up getting -1 as your answer, which is wrong. So only when Only if you get this data, new data at the bottom of the loop, then with the new data, you're comparing it to -1, the sentinel. Only if it is not -1, you're processing it. So remember, that's why this order is important for the sentinel control loop. So when the loop
Can
finishes,
you explain that one more time?
okay, the way I have written it, I put the C out and C in statement of getting new data at the bottom of the loop. And I do the processing of the data at the top of the loop. Now, it makes sense because normally, I mean, here we are finding minimum, so we had to do this before the loop, but normally you don't do something like that. You'll be getting the first data up here, C in num, this gets the first data, and you need to process that data. So very first statement inside the loop should be processing that data and then get the new data at the bottom of the loop. If you, by putting this at the bottom of the loop, right after getting the new number, we are going to the top of the loop and comparing to -1. Only if it is not -1, we are doing the processing. Then getting the next data. Only if it is not -1, we are processing it. So whenever the user enters -1, you go to the top of the loop. Num is now -1, loop ends. So you're not processing -1. You're not doing anything with the -1. Understand that? So,
Yeah, I understand it.
okay, so that's why this order is important. Whenever you are using sentinel control loop, the right method is to get first data before the loop begins. And inside the loop, you process that first data first, then get the next data. This way, the next data is checked against Sentinel before processing it. And that's important. If you write it in any other way, you're going to mess up something. Something is going to go wrong. For example, often I have seen students writing Sentinel control loop this way. Without getting the first data before the loop, they set the num to something else, some dummy value like that, 0. And then they write the loop while num is not equal to -1. The dummy value is not -1, so therefore the loop will start. And so inside the loop, they will get the actual data and see in num. And then you process that num by doing if num less than min. They set the min also to some dummy value initially, so that everything will work, you know. So if num less than min, then min equal to num. So anytime a smaller number is found, that will be copied into min. And then they close the loop. So it appears to be working, right? And then when the loop ends, you see out the min. There are a couple of problems with this approach. This is not acceptable approach because num equal to 0 is a dummy value and it's not -1, so the loop starts. And right after loop starts, you're getting the actual data and you're actually processing actual data here. So it appears to be right. And then you keep going to the top. As long as the last data entered is not -1, you ask for the next data. Okay, so that seems to be fine, but there's one major problem is when the num entered here is -1, that -1 is being processed. -1 is compared to min. And if actual data are all positive, then this -1 is going to be the smallest. And so the min is going to get the -1 as the smallest, which is wrong. You're processing the sentinel. You should not process sentinel because sentinel can make the whole answer wrong. So that's the major problem here, processing the sentinel, because as soon as you get the data here, you're processing. And only after processing, you are going back and checking whether the last data was -1 or not. But by the time you're checking, you have already processed it. So your program may have produced the wrong answer already. So that's why this approach is not recommended. The dummy values to get started is fine. You can use that. But again, that's also a problem because the min, you're starting min at 0, even if you start min at 1,000, you're assuming something. You're assuming something about the data which may not be correct. You normally have no knowledge of the data, and the program should work for any data. That's the standard goal when you write any program. It should work for any data. So this limits the data to be smaller than 0, right? If you start min at 0, or even if you start min at 1,000, then all your numbers are supposed to be smaller than 1,000. You know, you're assuming something. You should not assume anything because then the program is not going to work for any data. So this whole idea, the entire approach here is wrong. In the first approach that I explained up here, I did not assume anything. This will work for any data, and that's the right way to do it. Again, in the sentinel control loop problems, the whole thing is essentially the same, except the processing. This processing part right here, that's the only thing that will be changing. Otherwise, the structure of the loop should be same as this for any sentinel control loop problem. Okay, so problem number 4, let's go over that quickly. That's going to be a sentinel control loop as well. Let me erase this rest of it. This is wrong approach. I explained already, so I expect not to see in your homework. So what we need to do here is the num, we can use num as the variable, but in this case, the variable data type is going to be char. It's character. Char data, we'll call it. And then enter the data and see in data. Now you're receiving character data. And so the loop control is going to be data not equal to $sign. $sign is my sentinel. So when you write the cout statement inside the loop, enter the data or $sign when finished, something like that. You should tell the user what the sentinel is. So user will enter $sign when finished and see in data. So I read the data before the loop, first data I got before the loop, and as long as that data is not $sign, I will process. What is the processing I need to do? I need to see if that is a lowercase alphabet or not. And if data is lowercase alphabet is greater than or equal to 90 and no 97, and data is less than or equal to 122. So if it satisfies that, then it is lowercase, and in that case, cout data ENDL. That's the processing I need to do. And then get the next data, and with the new data, you go to the top. If it is not sentinel, you're processing it. So that's all you need to do for that problem. Okay, so I hope that helps. There are a couple of other problems I wanted to go over, but we don't have the time. Your assignment is due in the next class. Also, you need to watch the next video. Now remember, the what we go over in the discussion is just a couple of problems, and that's not all you need to do. You need to watch the video and learn everything there. There's so much more that you are learning from the video. The meeting, class meeting, we are doing some problems. That's not everything. That's not teaching you everything. So clearly, you know, the students who didn't watch the video couldn't do that one problem, the prime number problem, because they didn't learn it. So, you know, you can't do that. You're going to have to watch all those videos in the right order. So the next video you need to watch before next class, and that's going to be beginning a new topic, functions, and you have to watch the video to understand exactly what functions are. Don't rely on the class. Students who relied on the class got failing grade. All right, so I'll see you in the next class. Enjoy the rest of the day, everybody. I'll see you on Wednesday in person. Wednesday class will be in person.
So will this Zoom be on Blackboard?
What is?
Because in the beginning semester, you usually put the Zoom meetings on Blackboard, but you stopped doing it.
The discussion, yeah, it's a bit of a work. I didn't think it would be important. So you want me to put this on the put this video
Yeah.
on Blackboard?
Yeah, if you can, yeah.
All right, I'll do that.
Okay, thank you. Have a good day.
You too. Okay.